Assalamu alaikum and hello everyone. I welcome you all in today's webinar on Internet of Things and Industry 4.0, its application to civil and mining engineering. For today's webinar, our resource person is Rana Muhammad Asad Khan, who got his bachelor's in mining engineering from UET Lahore and pursued master's in mining engineering from the same institute. He did master's leading to PhD from Hanyang University, Seoul, South Korea. He has 13 years of extensive research, teaching, and field experience. During his PhD, he worked on the development of Internet of Things system for the underground mine safety. He worked on the structural health monitoring, blockchain, wireless sensor networks, and artificial intelligence for structural and environmental safety of underground structures. Prior to PhD admission, he was serving as an assistant resident engineer tunnels at Neelam Jhelum Hydropower Project, Muzaffarabad. Previously, he was attached with NUST Islamabad. Nowadays, he is serving as an assistant professor in the Department of Mineral Resource Engineering at BIMPak, Austria, Fachhochschule Institute of Applied Sciences and Technology, Haripur. Without any further delay, I would like to invite Rana Muhammad Asad Khan for starting his webinar. Thank you so much.
Thank you very much. I am Dr. Rana Muhammad Asad Khan. And first of all, I would like to say thanks to BIMPak and especially to the Dr. Vakas Tanoli. And we are here for to deliver our knowledge which we gained during our PhD or our higher education abroad. Our today's topic, that is the Internet of the Things and Industry 4.0, its application to the mining and civil engineering. I am already Dr. Vakas. He has shared my profile with you. And currently I am serving as assistant professor in the Department of Mineral Resource Engineering at BIMPak, Austria, Fachhochschule Institute of Applied Sciences and Technology. This has already been explained by the Vakas Tanoli. So I would directly move to the table of contents of this presentation. First of all, there will be a brief introduction to the Internet of the Things, its benefits, and what are the main parameters for building IoT system. Then IoT platforms and important phenomena in the IoT. Whenever we talk about the IoT, the platform, they have the importance of backbone in the whole system. We will discuss it briefly, what does it mean by the platform and how they can be established. Then next we will move on to the Industry 4.0. First of all, we will discuss its introduction. Introduction means the basic definitions. There are various organizations, leading organizations in all over the world. They have defined this Internet of the Things and Industry 4.0 in their own ways, according to their own requirements. So we have different sort of definitions. Then we will see some of the existing examples which have been adopted by the General Electric or the Trump, the German General Electric, GE. Both of these are the German companies. Then we will see some of the recent applications of IoT and Industry 4.0 in mining, engineering, and civil engineering. And at the end, we will see some of the challenges there and its adoption in Pakistan. Let me clear one thing first of all, that Internet of Things, that is abbreviated as IoT, and during my presentation it will be used as IoT, and the Industry 4.0 is its abbreviation is IIoT. IIoT is the Industrial Internet of the Things. This name was given by the Americans, while the Industry 4.0 is the name given by the Germans. Both of these indicates the same phenomena, but their wording is different. So during my presentation, IoT is for the Internet of the Things and IIoT for the Industry 4.0. First of all, let me remind something. Back in 2006, there was no iPhone, the smartphones. That was the, in fact, that was the starting of smartphones. Even though there was no blockchains, which are nowadays very much popular, 3D printers, drones, which have been used in various fields. Also, we are very much used to of the WhatsApp nowadays. All these now, recently we got the 5G, and even nowadays the working is going on the 6G. So all of these were not present in 2006. So in other words, we can say in a small era of about 14 to 15 years, the world, technological world has changed tremendously. So now we are connected. We got many machines to work for us. Similarly, first of all, the introduction. What is the IoT? First definition is from the IoT agenda. It's we can say an organization which leads IoT all over the world. They organize some of the conferences and webinars regularly to further modify the vision of IoT. According to them, IoT is a system of interrelated computing devices, mechanical and digital machine, object, animals, or people that are provided with the unique identifiers and ability to transfer data over a network. First of all, in the language of computer, we should give some identification to the things. And hello, am I audible to all of you? Hello, I am audible to all of you.
Yes, sir.
Okay, that's great. Uh, I was like us, like we are human beings, we got names for our identification. Similarly, in case of the Internet of the Things or IoT, we have to provide them with some unique identifiers. Unique, how we can provide the things unique identifier? We can define their IPs. IPs, we all know that whenever we connect our computers with the internet, we got an IP address. That IP address is basically the name of that thing which you are going to connect with the internet on the internet, on the world of the internet. So this is the first definition. In other words, Internet of the Things is the each and everything in our surrounding, if that is being connected with internet to share its data, to monitor some parameters, that becomes the Internet of Things. The another definition, IoT is a sensor network of the billions of smart devices that connect people, systems, and other applications to collect and share data. Again, this similar, we can say, same perspective, but in the different wording, that in the Internet of the Things, you can connect smart devices, you can connect peoples, you can connect systems so that they can work together. There are some other definition. One definition is from the Forbes. The IoT is the concept of connecting any device to the internet. Again, same phenomena, but the wording is different. This includes the everything from the cell phone, coffee makers. We can nowadays we can observe various machines in our surrounding which have been connected to our mobile phone. The fan of our room. We can see the example of smart homes. Smart homes, you can even control the light, you can control curtains, you can open and shut your main door. So all of these are the practical examples of IoT or Internet of Things. Let's have a look first of all at the benefits of IoT. If we are connected with each other, the things in our surrounding are connected to each other, it will definitely give to our society, give benefits to our society. First of all, in case of the processing plants or chemical plants, the safety is of the foremost concern. So it can provide us the safety. We can monitor the in case of the healthcare, we can monitor these senior citizens. It can also help us in improving the environment, and you can continuously monitor environment in your surroundings, and you can take I must say some remedial measurements to control your environment, to make your environment comfortable according to your desires. So all this can be done with the adoption of IoT. Similarly, it's new innovation. Even though the rest of the world, they have made tremendous progress in the IoT, and they have developed various numerous systems. But there is always a chance of innovation in case of the technology advancement. So it's an ongoing process. More you learn, more you will decide for the innovation. Business intelligence, you can monitor your business by sitting remotely, and you can even control your some of the machines which you have connected with the internet. If you are monitoring and you are controlling your business remotely, definitely it increases your efficiency and ultimately leads to the productivity, and at the end, to much extent, the profitability in a sense. If you are moving around by using your car at the various sites, in case of the civil engineering, you are moving around uh, between various sites, definitely it will cause you some cost of fueling, cost of your vehicle. So at the end, you can control your expenses. So definitely it will increase it increases the profitability, and also it gives you a sense of compliance. Newer, more effective way to monitor and report the compliance requirement. If there is, if you have some clients and they complain about something, then you can have more control as compared to the traditional approaches, in which is now common in our society. But specifically in Pakistan, we have not yet adopted the IoT in. I have not seen any much progress in the development of IoT in Pakistan. So we need to work together. It's a multidisciplinary research. In this research or in the development of the IoT, everyone can take part. The computer programmers, they can play their role by defining the IPs and by establishing the networks. If I am an agriculturist, then I must know my requirements, what I need to monitor for my crops, and what I need to take actions. That action I can tell to the computer programmer, and he can program and he can develop some sensors network for me. Similarly, if I am working in the civil engineering, I must know my requirements, what are my challenges, and how I can adopt the technology to tackle those challenges. Same is applicable for all other fields of our life, like mining, finance. Here are some of the building blocks of IoT. Let me explain you very simply. Basically, in an architecture of IoT, there are four layers. First layer we can see that is known as the perception layer. This layer is basically comprises of all the physical things in our surrounding. It can be a door of your room, it can be light, it can be fan, It can be anything which you have connected or with the internet. So these things you can make them smart by using some sort of these sensors. Sensors, they can be divided into different categories. Some of the sensors are just for the monitoring. They can monitor a specific parameter like the temperature of the room, and they can control the lights, the color of your light in your room. So the sensors, they can be established for your various perspective, various purpose. And some of the sensors are just for the monitoring. Another type of the sensors is known as the actuators. Actuators are the basically responders. Like if you wish to open the door of your room using your mobile, then you must install some sort of equipment which can open your. You must install some I must say, microcontrollers, so that they can control the handle of your door room door, and it can open and close. So there are the various type of the sensors which can be utilized for uh, according to the purpose. First is the perception layer. In this we can find all over the sensors and physical things. The second one is the communication layer. Obviously, if we have installed, if we have smart things, there is no benefit of those things until unless if they are connected to our main server or main or our network. How they can be connected using the any sort of the networks. All of these networks which we are using nowadays, the Wi-Fi, RFID, these are the wireless 4G, 3G, these are the wireless sensor networks, and we also have WLAN, wired LAN internet access. That is the wired connection. Any sort of connection can be utilized for the smart things to communicate. Again, this layer is known as the communication layer, and it includes various sorts of communication protocols. And the at the third number we have another layer that is known as the middleware, or basically it's your main server at which you collect all of the data, and that main server automatically processes, analyzes and processes your data for intelligent decision making. So all of the data is being processed over here in the middleware, and at the end it can control some of the applications. It can show results at your mobile screens, at your laptop, and also at the it can control the actuators. I have already explained, those are the somehow sensors, but they can respond. The simple sensors, they can only detect and monitor and send their data to the main server, while the actuators, they can respond. This is There is a little bit difference. So using these applications, using your mobile application, you can control the temperature of your room, light of your room, door, curtains, all of these things can be controlled using your mobile. And all this comes under the application layer. Again, in the application layer, we again have some of our physical things, but those physical things are being controlled electronically. Means we have installed some sort of the smart equators. We have attached smart equators with all of our surroundings, and we can control them using our mobile. Is it clear until now? Hello?
Yes, Dr. Asad, please continue.
Okay. So one of the backbone of IoT is the IoT platform. These are very much important. Even though we have installed some of the sensors to our things to make them smart, and they can communicate. But if we don't have any platform, then there is no you cannot take any advantage of those sensors. These platforms are just like the dashboards or mobile phone apps, so that they can communicate with the defined IPs which we have given, or which we have assigned the IPs to the different things. As I have mentioned earlier, that in the world of the internet, we have to give a name to all of our surrounding things. How we can give name to them? By defining IPs. So this platform is basically to control the IPs and to channelize the orders which we want to achieve which we want to achieve for our comfort. So we can see here in this picture the hardware, mobile, ubiquitous sensors, fitness devices, your automobiles, embedded hardware, all of these are connected with a platform. That platform basically provides you the user interface. Also, it processes your data and respond accordingly. And this platform is also helpful for the diversified information sharing. Means one of you is sitting at, let's suppose, Lahore, the other one is sitting in South Korea, the third member is sitting at some other country. So all of you have one common thing among you, that is the IoT platform through which you are getting all of the data, or you are monitoring your various devices. So let me remind you, and now we are moving towards the industry 4.0. And first of all, we can see some of the pictures in front of us. Initially, there was a stone, human utilized stones to grind the wheat to obtain flour. And afterwards, there was an innovation. Human, mankind started to utilize water energy to grind the wheat and to achieve flour. And after a few years, there was an new machine which was controlled electronically, and that can easily and efficiently grind wheat for you. But nowadays we can see an example of the entire flour mill, in which there are the processing plants which are being controlled with the computers, mass production, in fact, and all of this goes with the perfection. So here is the little bit industrial evolution. First, basic why we called it as industry 4.0, because there is a complete history behind this. So we need to understand what is industry 1.0, 2.0, 3.0. Initially, industry 1.0, it backs into the 1780s, when there was with the production of water and steam engines. Hello. Industry 1.0, it starts with the invention of steam engines, and so on at the 1870s. There was a revolution that is known as the industry 2.0, industry revolution, introducing mass production. Then mankind knows that because of increasing population, the demand was increased, so there was need of the mass production. So mankind started to produce all of the things in bulk. And in 1960s, that was the era of industry 3.0, in which we started to introduce computers in our systems. Using electronics and as the further progression in the automation production, we started to produce the things in bulk. Also, those our machine were controlled with the computers. Now we are in the era of Industry 4.0. That is the systems of the system. Mean various systems have been integrated over single system. Like in case of the flour mill, we can say handling of the wheat is a separate system, and the grinding of the wheat is a separate system, and then the packing of flour is also separate system. So a, an integrated solution which can combine all of the processes of an industry, that is the Industry 4.0 revolution. In fact, and even though now the world is moving towards Industry 5.0. Uh, should I continue? Okay. Industry 4.0 is the digital transformation of the manufacturing, production, and related industries and value creation processes. Again, here we have different definitions and according to the various organizations. Industry 4.0 is refers to as the intelligent networking. The simplest definition of Industry 4.0 is that it is a system of the systems. All of the various systems have been integrated over a single system. And one of the example of Industry 4.0 is the smart factory. If we consider a factory, and we can imagine there are various processes simultaneously occurring in a factory, and all those if are integrated over a single platform, and we can control all those processes, that is the Industry 4.0. And again, Industry 4.0, it's for the integration of various systems, we need various other technological advancements like com cloud computing is also necessary so that data can be shared equally and simultaneously among all of the participants. Obviously, we need artificial intelligence if we want to control or we want automate our processes. The artificial intelligence that plays very much a very vital role to control various processes, data analysis. Similarly, the mobile, so that you can use your mobile apps and you can control various processes and many other things. They are included in the Industry 4.0. I must mention here the Internet of Things is a subdomain of Industry 4.0. Basically, this small Internet of Things systems, when they will be integrated over a unified system, they can establish Industry 4.0, because Internet of Things can be specific to a process, but Industry 4.0 is specific to a complete industry. So what can be the building blocks of Industry 4.0 or IIoT? It's artificial intelligence, cloud computing, machine learning, cybersecurity, robotics, horizontal and vertical system integration. This is very much important. Horizontal and vertical system integration. Horizontal mean the system of same caliber, and let me give you an example over here. If we are successful in establishing a system of one entire industry, then we can interlink various industries through using the platforms, using this system. So in Industry 4.0 itself is a big name. It can integrate over all of our processes, especially related to the manufacturing, related to the civil engineering, and also with the other fields of our life. And again, in the case of the Industry 4.0, an important phenomena that is the creation of the platforms. Again, we need to develop some platforms which are helpful for the integration of the various processes. Again, the same 3D printers, they can also be controlled remotely. RFID beacons, AI, and advanced robotics, all of these are the pillars of Industry 4.0. In designing Industry 4.0, there are basically 6 design principles. Interoperability mean the one system should be synchronized with the other systems so that the interoperability can be allowed. The virtualization, decentralization, real-time capabilities, service orientation, and modularities. We can leave these because I guess all of you are from the civil engineering background, so this would be little off to our discussion. But in fact, if a computer programmer is involved with you, he would be interested in these things. Characteristics of the Industry 4.0. At the end, if we have developed the Industry 4.0, what characteristics it should contain? That you should be aware, you should be connected with your processes, you should be indulged, you should be a part of that process. That can be done with your connection with the processes, and the entire system should be responsive. If there is any anomaly in your entire system, then you can control your processes, you can control your production, and the system should be intelligent. It can be done with the integration of the artificial intelligence. Aware, how we can keep ourselves aware with our surrounding with the installation of various sensors which can monitor various parameters. Connected, again, we need some sort of communication protocol to transfer data from the sensors to the main server. Our main server should be responsive, that should analyze the data and it should analyze the situation, and it should also be intelligent to generate response. Here is an example of the smart factory. It is a complete structure in which we can see boards, 3D printers, cloud computing, big data, customers, even owners. They all are connected to each other using platform or the dashboard of that smart factory. So the platform or dashboard, they have unique importance in the entire generation of Industry 4.0. Industry 4.0 also plays a very much important role in the supply chain, because in case of the civil engineering and in most of our chemical industries, the supply chain uh, is very much of importance, because supply chain, if there is any cutoff in the supply, the whole production can be damaged. So the supply chain, that should be connected, and it can be done under the umbrella of Industry 4.0. Nowadays, this supply chain concept of the supply chain, for initially it was based on the Industry 4.0 Internet of the Things, but now the various industries, they have shifted their paradigm to the blockchain. Blockchain is providing advantages over the security and immutability of the data. You cannot change data in the blockchain network, and also the blockchain network is the decentralized. I must share one disadvantage of Industry 4.0 is that if we are establishing if we are controlling our entire factory using a dashboard which is being installed at a main server at one computer, that computer can be hacked at any time, means your entire factory is at risk. So now the paradigm has shifted, and the industry 4.0 is now considered the utilization of blockchain that can provide the decentralized mechanism, and you have very good control over your processes. Similar industry 4.0 is applicable to the supply chain, in which all of your key players like vendors, manufacturers, customers, and your provider, raw material provider, all are connected to each other through platform. Now we must see some of the examples of industry 4.0 which have been done in recent year in the world. German manufacturer Siemens. Uh, I hope we are familiar with this name. It's a very big name in the manufacturing. And previously, they were involved in the production of artificial, we can say, artificial hips and joints of the human being. It took their engineers to make artificial hip and joint around several days to customize for their patient. But now the 3D printers controlled remotely, they can print hip joints and other body parts of human being in 3 to 4 hours. So Siemens has adopted this concept of Industry 4.0, and they are now successfully developing the various parts. Similarly, another example from the Germany, Trump is a basically tool maker in Germany, and they have integrated all of their processes over the industry 4.0, and also they integrated with the social media so that their customers they can directly be involved or directly be connected with their processes. Similarly, GE is a big name. It's the General Electric. They produce various electronics in our which we are using in our surrounding, and it's all over the world. They are supplying the electronics item. They have also upgraded their system with the Industry 4.0 concept, completely automated and completely controllable. Smart building, nowadays there is the concept of smart buildings. These smart buildings are smart because they can efficiently use their energy, and we can all control the environment of entire building. We can monitor the environment of entire building using various sensors. Those sensors can transmit the data to the main server. Main server can analyze the data and respond accordingly. Suppose at the second floor, that is uh, second floor, if it is getting more heated, the temperature is being continuously monitored. The computer, attached computer, they can intelligently assess the situation, and they can turn on the air conditioning in the second floor. So all of this is possible nowadays with the utilization or help of the Internet of the Things and Industry 4.0. Now we are moving towards our main objectives. We can say the application of IoT and Industry 4.0, how we can adopt Industry 4.0 and Internet of Things in construction and mining industries. This is an important question. We have some of the examples in our in front of us from the civil as well as from the mining industry. Let me remind you one thing, that the nowadays there is concept of autonomous cars. Autonomous cars are the driverless cars. They can follow the maps and drive you to your destination. Initially, this concept was first time introduced back in 2003 or 2004. This concept was initially first time adopted by a mining company for the movement of their dumpers. So mining industry that it has accepted the innovations and they are really doing very well in their field. Here we can see some of the applications of IoT. IoT is for the smart cities, smart homes, self-driving cars, smart farming, smart factories, hospitals, and tourism. We can see some of the stores without any cashier. You can go through the machine, you can pass the products from the machine, and it can automatically deduct money from your credit card. Smart grids, structure health monitoring, all of these are application of Industry 4.0, Internet of the Thing. Basically, it provides the enhanced customer services, improve decision making, and increase the value of your business. Similarly, applications of IoT in civil and mining industry. First of all, IoT is applicable to control the machine. Most of the time in the civil civil construction side and mining construction side, most of the fatalities happen due to the collision of machinery with the personnel. So that can be controlled using technological advancement, especially IoT. Thus, we can enhance the construction safety. These technologies are also helpful, helping us in the project management. They are also helping in the fleet management, as I have mentioned earlier. The fleet management or the autonomous cars, autonomous trucks, they were introduced initially by the mining company. Similarly, at the far most important, that is the site connectivity. All of these processes can be controlled, monitored using IoT, both in civil and mining industries. In case of the civil industry, we can even now control the terrain. We can digitally collaborate among the engineers because as I have done work at one of the mega project in Pakistan, there was always conflict of our interest that the construction drawings which were provided at the sites, those were not updated, while the construction drawings issued by the design office, those were updated. So the technology, it can easily remove the clashes using cloud computing. The designers, they can upload their design in the cloud and you can see or visit the design in the cloud using your tablets and while standing at the site. So this is a great advantage, and in fact it comes under the heading of BIM, building information modeling, you all knows. And Internet of Things, it also provides you the analytics of your equipment, your supply chain, each and everything. You can get analytics about them, and also it can help you in the future planning of your construction and mining site. Similarly, here we can see another example from the mining. These various sensors have been installed at the mining machineries like RFID, accelerometer, gyroscope, motor pumps. All of these have been converted to the smart things. They can communicate over here. We can see again this same Internet of Things have four layers. One is the physical things, which can be converted to the smart things. They can communicate over various protocols, and we can have one processing plant, main server, which can identify the critical elements and it can respond back. This can simply be applied to the both mining and civil engineering. IoT of the application, it gives benefits of optimized operation, real-time analytics, increased safety, reduction in the cost and energy, and predictive maintenance. This is an important field nowadays, the predictive maintenance of the equipment, because the equipment breakdown cost billions of rupees to the construction and mining owners. So that if you are proactively monitoring your equipment, you can arrange the supply chain of the required tools. Then you can cut short your downtime of the machinery. The downtime of machinery, that is much of importance nowadays. That should be reduced so that you can enhance your production. So all of these processes are nowadays possible with the utilization of the IoT and at the larger scale Industry 4.0. Application of the Industry 4.0 in mining sectors, as the resources near to the surface inside uh, Earth, they are depleting with the passage of the time. So we have to excavate the resources which are lying at the greater depth. We know at the greater depth there is an issue, or there are challenges of high temperature and pressure at which humans cannot perform efficiently. So we need to develop some of the reports for such critical mining conditions that can work under such conditions. The autonomous truck, low operating cost, all of these are the benefit, and also an important phenomena that is for the extraction of rare earth metals. So in the mining sector, I must say this is the feature of IoT in mining sector, that with the passage of time, our resources are getting depleted. So we need to devise or identify new processes, automated processes, so that human interaction can be minimized. From current example of Industry 4.0 and Internet of the Things are from the Rio Tinto and BHP Billiton. These are the big names in mining. Even the Rio Tinto, the annual budget of Rio Tinto is about 1.5 times the budget of Pakistan. So you can understand how large is this company. Same is the case is the BHP Billiton and Anglo American. They are performing mining in the various countries, and their budget is almost equivalent to or greater than the Pakistan budget. There, in case of the mine machinery, two types of the automation can be done. One is the autonomous trucks, and other one is the autonomous drill machine. I have seen some of the drill machines. You can you can simply input the coordinates of the drill holes. They can go there, they can align themselves, and they can drill the holes for you. I have seen this machine. So these are the current examples from the mining industry. Again, the Caterpillar, they have also adopted it. The when I am saying the mining, I am also equally referring to the civil engineering, because the machinery is common in both of these. So they have Caterpillar has utilized in the Internet of the Things for the predictive maintenance of their equipment, and they have saved 8 million hours in their operations. So 8 million hours is a huge amount of the time. Integrated intelligent mining, these are the various processes which have been integrated, which can be integrated over the Internet of the Things or Industry 4.0. Similarly, in the case of the civil engineering, construction site, first of all, we need to divide it into the separate parts, and those separate parts, we need to establish various systems, and those systems should be integrated in for the Industry 4.0. This is the main concept behind. Now, at the end, I would like how to establish Industry 4.0. First of all, you need to identify the problem or challenges in your area, in your civil engineering, mining engineering, or either if you are working in the some processing plant. First of all, you need to identify the problem. Then you need to think how how you can utilize the technological advancement to cater this problem. And again, it's a multidisciplinary research. Then you need to develop some sort of the sensors. Sensors are available nowadays. You can simply purchase from the market and utilize them for your purpose. But the main thing is that you should make a platform so that all of your things, all of your system can be integrated over there. And then if you are successful with the platform, you can integrate artificial intelligence, you can integrate cloud computing and other cutting edge technologies to get analytics of your business or process. There are some of the challenges with the IoT, like the security. It can be hacked, as I have explained earlier. The main computer is can be hacked anytime. So nowadays, this paradigm is being shifted towards the blockchain. Blockchain, we can have a separate webinar like this related to the blockchain and the application of blockchain in our surroundings. At the end, I would like to say thank you to all of you for your patience to listen to me, and special thanks to Dr. Vikas Tanoli and BIMPak for organizing this webinar.